Now I'm going to go ahead and skip question 3 because the solutions are pretty detailed. So I recommend you take a look at the solutions posted on the website. And they go very in depth on explaining the answers to these parts. And instead I'll go on to do the last two questions, questions 4 and 5, as this video is getting pretty long. So question 4 asks us to compare TCP and UDP. Most of this discussion has been about TCP, but Sylvia briefly mentioned in class about what UDP is. UDP is an alternative L4 protocol that still provides an abstraction to the application, but doesn't provide any other reliability. So we can go and compare these side by side. Which of TCP and UDP provides reliable transport? Well, it's just TCP. UDP does not handle retransmitting packets, checking if they've been corrupted, etc., etc. On the other hand, UDP is indeed and does indeed limit messages to be a single packet. So if you have a bigger message, you'll have to send multiple UDP packets, and the application is responsible for this. Now, which of TCP or UDP has a source port in the header? It's actually both, because the IP header only has an IP source and destination. There is information about how to then multiplex and demultiplex this packet to reach a particular process or application running on the end host. So this is needed for both TCP and UDP. Without this, your data wouldn't know which application on this device to go to. Now, UDP, because it's just a single packet, has no handshake, it just gets sent. And so only TCP has this connection establishment handshake. For project 2, you're going to be using TCP. You won't be using UDP, and you'll see about that. And finally, it's optional to use the L4 checksum with this protocol under IPv4. This is indeed true for UDP. TCP has to use an L4 checksum because it is providing reliable delivery, meaning it has to catch not only cases where packets are dropped, but also cases where packets get corrupted. Whereas UDP, it's very minimal. It doesn't handle any sort of guarantees on a packet making it, whether it dropped or not, or just due to corruption. And so it is completely optional whether or not to use the checksum. A checksum in a UDP. Now, continuing on to these last short questions, 4 little multiple choice questions. The purpose of TCP handshake is, I'm going to circle all that apply. Well, on TCP handshake, we certainly are using it to establish a connection. So I definitely think that's true. Now, do we use a TCP handshake to indicate a packet's loss? No. The handshake is just for establishing our initial connection. No data is being sent yet. And in fact, we're not sending data yet in the handshake. We can piggyback data onto the very last ACK in the handshake, but the handshake itself is not for sending data. But we do use the handshake to exchange the initial sequence numbers for both sides to tell the other side what their initial sequence number is. So the answer here is A and B. Going on to question 2, which of the following is provided by TCP but not by UDP? Following the theme from the question we just did above, TCP does provide reliable transfer. It does provide congestion control. And how does it do this? By calculating a window and advertising a window that minimizes the data that's on the network when there's congestion. And it does provide a byte stream abstraction, whereas UDP's abstraction is per packet. You construct a packet that you want to send. Now, TCP does provide multiplexing and demultiplexing to and from application processes using port numbers, but UDP does this as well. So the answer here, C applies to both, and so it isn't true that it's only provided by TCP and not by UDP. So the answer here is A, B, and C. A, B, and D. Then question 3 says, what flag is usually set on the first packet in a TCP exchange? And the first packet is going to have a SYN flag set. So remember, RST stands for reset, and that flag is used to rapidly tear down a connection, not gracefully exit a connection. A FIN flag is used for, gracefully ending a connection, and IETF isn't any sort of a flag. It stands for Internet, perhaps Expansion Task Force, something task force. Exploration Task Force. It's not even a type of flag. And finally, for question 4, we say, what message type does TCP send to abruptly terminate connection? Well, I gave this away a second ago. It is the RST flag. SYN is used for the initial handshake. IETF isn't even a type of a flag. And FIN is used for graceful connection. With that, that marks the end of our discussion. And I will see you all in class. Bye.